Welcome to a logical reasoning video on series from careerright.com. This is an important topic of placement tests, job interviews and entrance exams where many candidates struggle. They are not able to quickly find the relation in the series and hence they waste a lot of time on the question. Many even at the end leave the question and some of them don't even attempt the question. But today we'll see some approaches and tips to quickly solve the questions on series. Along with this, you can check out latest job offers offerings in the market on careerright.com. The profile which you submit will be shared directly by us with the employers. You will also get to know of interview experiences shared by other candidates. So now let's start with series. First, let us take a look regarding types and tips of series. Okay, now over here, types means series can be of three major types. Okay, 99% sums are related to this only. One is numeric, that is related to numbers. Second is alphabets, that is letters. And the third one is alphanumeric, that is letters plus numbers, combination of letters and numbers. And the fourth type is generally asked, that is symbols. We are not going to deal with it because generally symbols has no logic. Whatever logic is needed for solving symbol series, it is already given in the question. Okay, so no need to consider symbols over here. Here we'll focus on the most important topics where 99% sums are asked. That is numbers, letters and letter numbers or alphanumeric, right? Now series sums can be asked in three formats. Okay, these are three types. There are three formats of sums. One is find the next number in the series or find the next group of letters or next letter in the series. Then is find the missing number or the missing alphabet or the missing group of alphabets. The third one is find the odd man out or find the odd number or the odd alphabet or the odd group within the given series, right? Now we have seen the types, we have seen the format of questions. Over here in the types, these three types have many subcategories, okay? These subcategories are, you have already seen these subcategories, it's nothing big in it. We are going to see each and every subcategory so that you will be able to understand what kind of sums are asked and how to approach them. Okay, now let's move on to some tips regarding series. While approaching the series sum, please understand the first thing you have to do is to find the relation between the given elements. Okay, and second sum is using the relation, solve the question and get the answer. Now, how to find a relation, okay, or what kind of relation we should search. Now, whenever we are talking about finding a relation, let us assume that this is a series. 3, 4, 5, 6. This is a series. Now, in it, say if we take this element, we have to find relation of this element with the previous element and the next element. Then if you move on to this element, find the relation between previous element and next element. If we move on to this element, find the relation between previous element and next element. Then you'll get a pattern, okay? This pattern is what we need. And using this pattern, we can solve the question. So now, how to go on or how to approach in finding the relation? Very easy. What you need to do is that, say this is a series, okay, this is a series 1, 2, 3, 4, 5, 6, and we have to find the pattern in it. What you need to do first is, let us find the difference between two elements, okay? This is for only for the number series, okay? I'm not talking about letters and alphanumeric. For that, I'm going to tell you a different strategy, but for numbers, it is important. Please pay attention over here because this will help you get the series pattern very, very quickly, okay, or easily. Now, over here, let us find the difference between two numbers. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. Here you are seeing that there is a steady difference or a constant difference. If the difference is not constant, okay, if the difference is like first there is a difference of 1, then between the second and third element the difference is of say 7, then third and fourth the difference is suddenly 25, and fourth and fifth difference is say 200, fifth and sixth difference is say 5500. So this difference is increasing arbitrarily and it is very, very huge. It is not going steadily, something like that. It is increasing it is going very high. There is a very steep rise in the difference. In such cases, always remember that the series must be related to square of number, cube of number, or multiplication, okay, or simple multiplications, right? If this is the case, if the difference between the numbers or elements is very, very high, it is increasing very highly or very quickly, that means the series is related to squares of numbers, cubes of numbers, multiplication of numbers, okay? Now, we'll tell you what exactly we mean by square, cube, multiplication, but just remember this. I'm going to repeat it afterwards also, but still remember it. If the difference is constant like this, 1, 1, 1, or if the difference is increasing very slowly, like here the difference is 1, then here the difference instead of 1, it becomes 3, then here the difference becomes say 7, then here the difference becomes say 10, here difference becomes say 15. So it is increasing, but it is slowly increasing. It is not increasing very arbitrarily and all that stuff. So over here in this scenario, the series must be related to addition, okay, addition, subtraction, multiplication, division, okay, or the series might be of prime numbers, or it might be a Fibonacci sequence. I'll tell you what all these things are: Fibonacci sequence, prime numbers, addition, subtraction, okay? But just listen to what I am saying. So these might be types. There are many more, okay? Miscellaneous types also are there, or combinations is also there. So these two rules which are there, they are very important while approaching a sum related to series. Always keep these rules in mind. That is the reason I have told you right at the start, okay? Now what we'll do is, now we'll first see what are the type of series, okay? We'll see what is numeric series, what is letters, what is alphanumeric, and then we'll try to, while solving the sums, we'll try to understand how to approach the sums related to series, okay? A more detailed approach as to how to identify what kind of series it might be, okay? Moving on to the first type, that is the numeric series. Number series, numeric series or number series has a lot of subcategories, okay? We'll denote a few prominent ones or the basic ones which are extremely important, and most sums are related to that, okay? First one is related to addition or the addition series. Take a look at this example: 19, 25, 32, 40, question mark, and we have 59. Now in this series, what we have learned first, always find the difference. 25 minus 19 is 6. This is 6. 32 minus 25 is 7. 40 minus 32 is 8. That means that 19 plus 6 you will get 25. 25 plus 7 you will get 32. 32 plus 8 you will get 40. So here we are finding difference. So here a pattern is emerging, that first 6 is added, then in the second element 7 is added, in the third element 8 is added, that is one more. So in fourth element, how much should be added? Plus 9, okay? Then you will get some answer over here, and in that you will add 10 and you will get 59. So let's see whether we are right or not. 19 plus 6 is 25, plus 7 32, plus 8 is 40, plus 9 is 49, and 49 plus 10 is 59. So this series looks complete. It is following a pattern. First 6 is added, then 7, then 8. Such kind of series is addition series, where things just are just added, okay? To the previous number, you add something to get the next number. Again, you add something over here to get the next number. Now here there's plus 6, plus 7, plus 8, plus 9, plus 10, okay? They might even have add plus 1, plus 1, plus 1, or plus 2, plus 2, plus 2, or they might even add, say, odd numbers, right? So first they'll add 1, then they'll add directly 3, then they'll add 5, then they'll add 7, then they'll add 9. Only odd numbers might be added, or only even numbers might be added. Addition can be of anything. So when you determine that it is an addition series, you just need to find out the pattern as to what exactly is being added. Same way you have the subtraction series, okay? In subtraction series, instead of addition, it is subtraction. For example, 102, 85, 68, question mark, 34. What is the difference? 102 minus 85 is 17, 85 minus 68 is 17. So 102 minus 17 is 85, 85 minus 17 is 68. So here also it should be subtracting minus 17, subtracting 17, that is 68 minus 17, you will get 51. Again from here you subtract 17 and you will get 34. So here a constant value has been subtracted, okay? So whenever a series is increasing, it is addition or multiplication, okay? Next number is greater than previous number, okay? So 32 is also greater than 19, 40 greater than 19, 49 greater than 19, 25. So it is increasing like this. So it is addition or multiplication series. In subtraction, the numbers decrease like this, okay? Even in division, the numbers will decrease, right? Now next, like addition, subtraction, like we have talked about right now, multiplication series. In multiplication series, the number is multiplied by some number to get the next number. Like I'll give you an example. Take a look at this series: 1, 2, 6, 24, 120. 1 to 2. Okay, what is the difference? The difference is 1. 6 difference is 4. 24, here difference is 18. 20 minus 24, 120 minus 24, difference 96. See, the difference is increasing very quickly. That means this must be related to multiplication, okay? So let's try to think of some multiplication, like 1 into, what is the relation? 1 into 2 is 2, okay? So we found this relation, 1 into 2 is 2. 2 and 6, what might be the relation? We know 2 into 3 is 6, correct? Now 6 and 24, what can be the relation? 6 into 4 is 24. So what is happening is that the next number which is there, it is taken over here and it is multiplied by something. First it is multiplied by 2, then 3, then 4. So this must be multiplied by 5, right? This should come over here and this must be multiplied by 5. So 24 into 5 becomes 120, right? So what will be the next number? Write it 120 over here. Here it is 5. 2, 3, 4, 5, 6. 120 into 6 will give you 720. This is the answer. This is multiplication. It might also happen that each of the number is multiplied by a constant number, okay, like say 6, 12, 24, 48, 96. 6 is multiplied by 2, you get 12. 12 is again multiplied by 2, you get 24. 24 is multiplied by 2, you get 48. 48 is multiplied by 2, you get 96. Okay, such multiplication can also be there. Same way, there is division, there is nothing to it. Okay, this is the division series. Take a look at it. Okay, 2, 1, 6, 72, 36, 12, question mark 2. Okay, here the difference which is there, it is falling. Okay, here we saw if it is rising very quickly, it is multiplication. If it is falling very quickly, exactly opposite that it is will be division. Okay, let us see what division. 216 when it is divided by 3, you will get 72. 72 when you divide by 2, you will get 36. 36 again when you divide by 3, you get 12. So divide by 3, divide by 2, divide by 3, divide by 2. Answer here it will be 6. Again divide by 3, 3, 2, 3, 2, 3, you will get answer as 2. So our answer is correct. The here it will come, here the answer will be 6. This is division. We are going to see examples of all of these. So don't worry, don't panic, there is nothing to it. It is very, very easy. Now after these basic numeric series, let us move on to some special numeric series. Now special numeric series, I mean they are not that special, I just said it for like effects purpose and all that stuff, but over here see there are some numeric series which you should know for sure because many a times sums are asked on them. The first one is regarding squares, that is squares of a number, squares, cubes and the series which are near to it. I'll explain what it means near to it and all that stuff. Okay, you must know squares of numbers, squares up to 30, and you must know cubes of numbers up to 10 because it is very, very useful to decipher the series. Also it would be useful for your quant, right? So first of all, let us see an example of square series or numbers near it. Say take a look at this series 0, okay, not this, 0, 3, 8, 15, 24, 35, question mark 63. Now if you observe closely, what do we see over here? Difference is 3 minus 0 is how much? 3. 8 minus 3, difference is 5, here difference is 7, here the difference is 9, 11, okay. Question we don't know over here, so it is increasing, okay, it is steadily increasing, right? So this must be related to addition, subtraction, multiplication, something like that. Now over here we have taken smaller values, okay. If you go on increasing over here, you will realize that it is increasing more and more, the difference is increasing more and more, okay. Over here, if you observe very closely, this is 0, 0 is nothing but 1 minus 1, 3 is nothing but 4 minus 1, 8 is nothing but 9 minus 1, 15 is 16 minus 1, this is 25 minus 1, this is 36 minus 1, question mark, we don't know. This is 64 minus 1, and this is nothing but 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So by default here it should be 7 square, this is 8 square. So 7 square minus 1. Now you will say that by looking directly at this, how will we guess that it is a square series or something like that? That is the thing of series. Whenever you get a series, if you are not able to think about what series it might be, you have to apply some tricks like, okay, is this nearer to some square, is this nearer to some square, is it a square of some number, like that, okay. Here it is 4 square minus 1, it is 4, 2 square minus 1, 3 square minus 1, 4 square minus 1, all that stuff is given over here. This is what we mean by square series, or a series which is nearer to squares. If you talk about cubes, what you can have, this is a cube series, 64, 125, 216, 343, okay. Observe carefully, this is 4 cube, this is 5 cube, this is 6 cube, and this is 7 cube, okay. These are the cubes, so this is a series. Now after this, let's take a look at another very important special series, and that is nothing but prime number series, okay. You know what are prime numbers? Prime numbers are those numbers which are divisible by themselves and 1. Apart from that, no other number, okay. So we know 1 is not a prime number. Prime numbers start with 2, 3, 5, 7, 11, 13, 17, 19, and so on. These are prime numbers. This is the prime number series. It might happen that they might give you an addition series, okay, and in that, while adding, first they'll add 2, then they'll add 3, then they'll add 5, then they'll add 7, okay. So such kind of, you need to find out what the addition is, and then you need to see, okay, this is like prime numbers are getting added. So after 7, 11 is the next prime number, so in the next element I have to add 11. After 11, 13 is the next prime number, so I have to add 13 in the next element to get the next element, okay. This is prime number series. The numbers which are not prime are called as composite numbers, okay. The rest of the numbers like 4, 6, 8, okay, 9, 10, all 12, all these numbers are composite numbers because they are not prime. Now after prime number series, a very important series I am going to talk about, that is the Fibonacci series. Now what do we mean by the Fibonacci series? Over here in Fibonacci series, the best part about Fibonacci series is that, say this is first, second, third, fourth, fifth, sixth element, okay. Addition of this element and this element will give you this element. If you want this element, then add this and this, you will get this element, okay. If you want this element, you will have to add this element to this element, and then you will get this element. So Fibonacci series always starts with 2 ones, that is this. See, I'll draw over here 1 and 1. Fibonacci sequence starts with this and it goes on up to infinity. So this is the first element, this is the second element. So what is the next element? Add this and this. What you will get? 1 plus 1 is 2. What is the next element? Add the previous 2 elements. 2 plus 1 is 3. Next, 3 plus 2 is 5. Next, 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. 21 plus 13 is 34. 34 plus 21 is 55 plus is 89. 89 plus 55 is 144, and so on, okay. This is the Fibonacci sequence or the Fibonacci series. So in exam, okay, or in paper, they might give you the series right from here to here, like that, in between only. So you just need to check whether addition of these two numbers is this, these two numbers is this, these two numbers is this. If that is the case, that means that it is a Fibonacci sequence and you just need to add these two numbers to get the next number. Okay. After Fibonacci sequence, I am going to tell you a very important point. Please pay attention. Okay. It is really very important. Sometimes it might happen that a series is given, like say 1, say 2, 3, 4, 5, 8, 7, 6, 5, 4. Okay, this series is given. Now here you observe it increases. Here from 1 to 8 there is an increase. 8 to 2 there is a decrease. 2 to 7 increase. 7 to 3 there is a decrease. So if there is such increase, decrease, increase, decrease, that means that there are two possibilities. One is there are two different series, just like I wrote over here 1, 2, 3, 4, 5, and other series I wrote 8, 7, 6, 5, 4. There might be two different series, or there is another possibility, that is that two different operations are going on. That means once it is getting here some addition is there and here subtraction is there. Here addition is there, here subtraction is there. Something like that is going on. Okay. So two different operations are going on, or they are two different series. You have to think in these ways. We are going to see an example of it, but still I am telling you right now. I'll explain it again during the example also. Apart from this, say if you are not able to understand how to solve a sum, what you need to do is you just need to break the number and analyze each number individually. That also we are going to see. It might also happen that say if a series is A, B, C, D, E, F. So instead of giving directly A, B, C, they might write C, B, A. We have FHE, we have NPM. There must be some relation between this group and this group. Let us find out what the relation is. So if there is such increase, decrease, increase, decrease, just need to break the number and analyze each number individually. That also we are going to see. It might also happen that say if a series is A, B, C, D, E, F. So instead of giving directly A, B, C, they might write C, B, A. They might reverse it. Okay. F, E, D. Okay. They might reverse it and give the series even. That is the possibility. You have to check that also. Okay. So we have seen some of the series right now. Let's move on to, we have seen numeric series. Let's move on to the alphabet series or the letter series. Alphabet series are a bit easier than the number series or the numeric series. And the thing that is going to help you a lot when it comes to alphabet series and alphanumeric series over here. Okay, there are two types of some ways to think about it. What you can think is that after A, they have given directly F. Okay, A to F, what is the distance? 1, 2, 3, 4. Okay, 4 is the distance between A and Z. So what? There are two type of sums that may be asked. It might be like this: A, B, C, D. That is, each element is just one letter, and sometimes there may be groups instead of letters, like A, B, C, D, E, F, G, H, I, J, K, L, and we have to find the next three letters. Okay, so here what we have to do: take the first letter, find relation with the second letter. Take the second, find relation with the fourth, and also we have to find the relation of this group with this. Okay, so such things are there. It is very easy actually. Once you draw the chart, you will very easily be able to guess the answer or the pattern. Let's take a look at few examples so that it would become more and more clear. Now look at this example: CEH. Okay, question mark. then you have O, Q, T, then we have U, W, Z. We have to find what comes in place of question mark. C, this is the first letter, okay, C is over here. E, one position, second position, so plus 2, you will get E. E, F, G, H, okay, plus 2 again. What you will get? No, actually C, D, E, only one over here, only one skip is there, and from E to H, one skip, second skip, okay, so 2 skips are there, and then the third letter is written. Over here for O, Q, T, O, again one skip, O is over here, one skip, you get P, okay, one skip. Q and T, one skip, second skip. There are 2 skips over here. Again here also one skip, here also 2 skips between W and Z. So whatever answer will come over here, okay, whatever options would be given, A, B, C, D, E, whatever options are there, we have to see that in that option, the whatever is given, like for example, they give say M, O, R, we have to as A, then we have to see if between M and O one skip is there and O and R 2 skips are there. If that is the case, that will be our answer. Okay, see how easy it is using this table or this whatever rough note you have written for of A to Z and the positions. Let's take another example. B, D, A, F, H, E, then question mark, then N, P, M. Now over here B and D, what is the difference? Here B is over here, B and D, difference is 1. So there is only one skip, okay, C has been skipped. B skipping C, then we get D, okay. Then D and A. Now D, A comes before D. So 1 before D is C, 2 before D is B, and 3 before D is A. So what we can say between D and A, the difference is -3, okay. 1, 2 and 3. This is the third. So -3. D to A, when we go 3 places back, we will get A. Same way over here. F, G. G has been skipped. So +1 and directly we get H. Now H to E. Again 1 over here. Look at the table over here. E and H. 1, 2 and 3. Again -3 skip. Here also. N to P, 1 skip, and P to M we have to go backwards 3 times, that is -3. The third letter backwards would be M. So whatever would be the answer over here, we have to see that we have B, D, A, okay, F, D. Subtract everything, subtract the original position from 27, you will get K, 6, then we will have 1, N, 3. Find the next one. This is 1, okay, not I, this is 1. Now over here, this is an alphanumeric series where we have alphabets and numbers. What to do whenever you find an alphanumeric series? The first thing that you have to do is whatever numbers is there in the group or element, you have to see if they are related to the position of the alphabet, okay, position or reverse position of the alphabet, right? So 2 and 2, if they are related to position of E or not, or reverse position of E or not, that we have to check. Now after that, say if it is not related to position, you have to find whether these numbers are related to each other. Like if there is each other, okay, I'll write it over here, each other, so you will not forget, make a note of this. Now 2 and 2, we know 2 is equal to 2. 1 and 9, we don't know what relation it is there. 1 and 6, again don't know what relation. 1 and 3, don't know what relation. So over here we should try to find if they have any connection with each other, okay. Now if that is not the case, then try to find relation with numbers of other groups, with numbers of other groups. Like for example, here we have 2 and 2, okay, 2 and 2, is it related to 1 and 9? Is it related to 1 and 6 or 1 and 3, or this 2 related to 1 or this 2 related to 9? Like that we have to try to find. Or what you can do is take this as 22, take this as 19, something like that. We have to find the relation, okay. Now even if that is not possible, then actually parallel to this, we also should check out if the letters are connected to each other. Same thing we have to do for letters also, right? So whatever alphabets are there, we have to find out the relation for those also. And in this trial and error, you will get the pattern. Now we'll see an example. We'll solve this example also. as well as we'll see another example as to what we are talking about. Now this sum which we are saying, or the question which we are seeing over here, it can be solved in two ways. There are two logics. You can use any logic. Okay, I'll explain both the logics. Over here 2 is there, 2 is there. What we have to check whether it is related to position of the letter. So 2 and 2, no, E position of E is 5. So 2 and 2 is not related. What is the reverse position of E? 27 minus 5, 22. Okay, this 2, this 2, this 2, this 2. Let's check over here. 1, 9. Okay, what is the reverse position of H? 27 minus 8, 19. Yes, we are finding a pattern. 1, 9 means 1, 9 over here. So 1, 6, 1, 3. These must be the reverse positions of the letters, right? So whatever option is there, we have to check. There we have to see if whatever the option is given, it has the, for example, if the option is like this, P and say 0, 9 or 9, 0. If this is the reverse position of P, then we can select it as the correct option. Okay, so check out the options. Now what is the second logic? Over here 2 and 2 is 22, 1 and 9 is 19, 1 and 6 is 16, 1 and 3 is 13. If you observe closely, what is happening is that minus 3, minus 3, minus 3. So by default next one will be minus 3, this will be 10. So that means the three positions which are there, this is 1, this is 0. We have to find the letter E and H. E is over here, H is over here. There is a gap of 2. Okay, they have skipped 2 letters, H and K. One letter skipped, second letter skipped, K. K and N. One letter skipped, second letter skipped, N. N and next what is there? One letter skipped, second letter skipped, Q. So answer is Q. So answer is 1QO. So this is the second way to solve the same sum. You can use any number of ways, just get the right answer. Let's take another example. H8, L12, O15, S19 and next one. Okay, here H8, L12, O15, S19 is given. What is number? Check if it is related to position. H position is 8. Yes.